I'm Henning Stein with One Business World, and I'm delighted to moderate the session under our theme, One Artificial Intelligence, Deploying AI in Business. To give you the helicopter view of our guest organization today, Hitachi Vantara is the data-driven heart of the global Hitachi giant. They are the architects helping the world's most complex enterprises bridge the gap between their physical operations and their digital future. Whether it is powering smart cities, optimizing global supply chain, they provide the storage and the cloud infrastructure that turns raw data into actionable intelligence. Our guest today is their Senior Vice President and Global Head of Strategy, Simon Ninan. Simon is the strategic leader who understands that deploying AI at scale requires more than just a good model. It requires a resilient, secure, and most importantly, an integrated foundation. Simon, welcome.
Henning, thank you. My privilege and pleasure to be here. So appreciate the kind introduction. And as you said, it's about turning data into outcomes. It's about making enterprises actually successful and powerful using the concept of data. And so with that, I have titled my presentation for today, Data for What? Strategies for Real World Impact, right? And you'll see not just the big shifts in data that are enabling this transition, some of the big transitions that we're seeing today, but also specifically, I'll use the example of Hitachi and Hitachi Vantara for how we enable this shift. I'll start by actually, posing a question that all of us have asked it many times, right? Data is the new oil. Data is new oil. That phrase was, I think, coined in the 1990s. But there is a difference. There's a big difference between data and oil. Unlike oil, data is not a finite resource. Data can be multiplied. Data can also be shared and be in many hands at the same time. Data can be highly democratized. Anyone can generate and capture data. These are differences, right? But unfortunately, the things that seem to make data more powerful than oil can also significantly weaken it. Yeah. When you ask me what's the definition of AI, sometimes I define AI as absolute insanity. Take a look at the couple of charts on the left-hand side. These are Google Trends. And if you know, Google Trends is basically looking at what people are searching for. It's an indication of interest on the internet, right? The searches, and I don't think you can read the x-axis, but you'll see that both searches for AI ROI and the AI bubble started to spike sometime around April and May of last year and started to grow and grow. And we've seen multiple times where it spiked. Why is this happening? Right? A lot of big promises have been made with AI. AI is, $3 trillion, depending on who you ask. The number is more than that, less than that, kind of around that number. But there was a big study that came about last year, which is coinciding with when this search for AI ROI, AI bubble started to come up. There was an MIT study that basically said 95% of enterprise projects in AI do not move from pilot to production. And that rattled tech investors. Compound that by basically prominent CEOs like the Microsoft CEO Satya, or even the OpenAI CEO Sam Altman, basically saying, you know what, the industry is a little bubbly, or AI has yet to deliver real value despite massive investment and massive promises. And earlier this year, we've been seeing a lot of shocks related to AI, especially as new AI innovation has come in and completely started to disrupt certain industries like the software as a service industry. How do we get ahead of this, right? I want to take a step back first and talk about the data explosion. This is data big bang. The fact of the matter is that data is exploding in volumes that are just unprecedented. Just within the last 15 years, we've seen 100x growth. That's 200 zettabytes per year. What is a zettabyte? It's 10 followed by 21 zeros. Yeah? In fact, data is growing so fast that in the last couple of years, 2 new units of measurements were announced for the first time. A ronabyte is 10 followed by 27 zeros. A quettabyte is 30 zeros. We're introducing a new mechanism called yottabyte, right? Not mechanism, but measure, yottabyte. If you just put this also in context, until the year 2003, since the dawn of civilization, there was a total of probably 5 exabytes of information that were created. Now that information is created every 2 days. Let that sink in. And that's being driven by a whole bunch of really, big critical trends. Yeah. We're seeing data center footprint grow by 3 times in the next 5 years, according to predictions from Gartner. We're seeing a lot of repatriation of public workloads and duplication of these. We're seeing the growth in machine data. We're seeing, for example, if you just think of a single self-driving car in a single day generates 4 terabytes of information. Every self-driving car in a single day, 4 terabytes of information. And that's not information that can be discarded. It needs to be stored. It needs to be managed for regulatory and other reasons, right? We are just not ready for that kind of explosion of data. From managing the volumes and complexity of data in the enterprise to handling the stress on the power grid, we are not ready. It's not just that, but data is also expanding in complexity. And to kind of expand on the Big Bang analogy, I've created a little bit of a cheesy slide here, but it basically says the new data physics is the multiplication of complexity across data form factors, data locations and systems, data performance and characteristics of timing expectations, the users or the personas and the data ecosystems that surround the use and creation of data, and regulations as well. All of this leads to an exponentially multiplied complexity calculus. I had to come up with that because, of course, that's the new EMC square. All this makes it feel like this. We're standing in front of a data tsunami. And our current approaches, to be honest, aren't helping, right? Many, many years ago, a couple of decades ago, right, this whole concept of being agile came to the front of our lexicon, right? And as teams started to try to be agile, it led to more federated teams. It came with downsides. You're trying to achieve the upside of agility, but the downside of it is the creation of silos. And when you have silos, and you're like, okay, it's okay, we'll put all the information in data lakes. But when you start to kind of like say, we'll dump it there and we'll figure out the problem later, handle the issue later, it leads to reactionary behaviors. And when that happens, what you're actually creating is you're creating bottlenecks for agility. Think about it, right? The problem that you're trying to solve through agility, you've built all these mechanisms, and now you're actually creating more problems for the future. And so that leads us to 2 critical questions. When you try to move fast and break things, are you actually breaking the things that could allow you to move fast in the future? And is this a case of IT getting lost in IT's world and getting separated from solving real business problems that business owners look at? Fundamentally, I think it's fair to say that the data strategies of yesterday won't work so well tomorrow. And in that context, I want to tee up for you 5 key shifts. These are, I'm sure you can talk about a lot more, but these are some of the 5 big shifts that are happening in data strategies as enterprises think about how they evolve for the future. Let's break it down. Shift number 1 is the shift from quantity, as we just discussed with the data Big Bang, to quality. And the chart is kind of a telling chart in itself, right? If you look at this data, which shows the top impediments for businesses in moving an AI application from pilot to production, the number 1 reason that is cited far and away above everything else is data quality. Data quality is the greatest inhibitor to realizing AI ROI. In fact, you can argue about this data. Different studies have been done, but more than 50% of AI projects unable to reach scale. While many organizations are seeing increases in data quantities, data quality is holding them back from actually tracking and finding real ROI from their data. More than nearly 70% of people that responded to surveys have said that they're slower than their competitors in reacting to market changes because of lack of access to data or lack of access to quality data. Here's a chart that indicates an exacerbation of the problem. The normal growth of data, and the chart, if you can see how the bar is labeled, it say real data is growing at a pretty healthy, aggressive pace. But the lighter blue, exponentially growing chart is the growth in synthetic data. It's artificially generated data. In fact, if you look at a couple of quotes on the right-hand side, the Epoch AI said that LLMs could run out of fresh human-generated data by 2026. This year, everything that could have been put into these LLMs to train them, the cumulative sum of human knowledge has been exhausted in AI training, according to Elon Musk from last year. Here's the problem, though, right? Because we're talking about data quality. When your base data has issues, and then you're building synthetic data on top of it, issues that present in the base, quality issues that are present in the base then get exacerbated and multiplied. And this is what we call, if you haven't heard the term, model incest. It's bad models feeding on themselves. And it leads to model collapse, the loss of quality as models are trained on more and more synthetic data. This is the real problem, right? We have, as Hitachi Vantara, done exhaustive studies on this, right? And we have come up with our own framework. I'm sure you can find frameworks from a variety of places, but just think of it as when you talk about data quality, it's not one thing. It's accuracy, it's completeness, accuracy about reflection of reality. It's also about consistency across is the data being uniform across formats? Are we following regular conventions? Is there duplicate data? Is the data reliable? Is it timely? Is it traceable? Right? All of this, but underlying all of these is the concept of trust. Here's the problem with trust. Trust is hard to win, but trust is easy to lose. When you're trying to drive adoption in the enterprise, if you've lost customer trust, if you lost user trust in what is being produced as part of the AI use case, adoption is going to be really hit. One bad experience cascades down to the others. You have to make sure that you get it right from the get-go, and you build very quickly towards quality. Mark Twain has often been called the original data scientist. He said a quote in one of his books that he said, it ain't what you don't know that gets you into trouble. It's what you know for sure that just ain't so. Isn't that a good description of the importance of data quality and making sure that you're not dealing with garbage? Someone else said that data is like water. Neglect its quality, and you have to fear the indigestion. Yeah. Let's talk about shift number 2. This is the shift from waste to worth. Many people are familiar with the iceberg analogy, right? 10, 20% of what you see above the surface, and you can call that visible data. Very often that is structured data. Often what's under the surface, the 80 to 90%, is either unstructured data, it's vastly distributed data. We call this often dark data because you don't know where it sits and you don't know who has control over it, and you just don't have control over the data. In fact, there's a very useful stat that you see on the right-hand side but it's in a kind of an alarming stat. This is from Deloitte, but the stat says that of all the data that sits in the average enterprise, right? And remember the scale of this, we're talking about 200 zettabytes across the world in 2025. Only 37% of that data is useful if analyzed. Even if analyzed, only 37% of the data is useful. 63% is potentially what we're calling data waste. A few years ago, and this is an article from Forbes from a few years ago, right? There was an article, the headline said, digital exhaust, the most valuable asset your organization owns but isn't using. What is the concept here? The concept was all data is valuable. Make use of all data. Digital exhaust was not a negative term, it was a positive term. It was basically saying capture the data from every single transaction, from every single interaction, and you can find a way to make it work for you. You can find a way to monetize it. Here's how I think digital exhaust has played out over time. That exhaust has created digital waste, digital burdens, digital inefficiencies, and of course, digital loss of profits. The second question I want to tackle over here is it really an asset, or does data have the potential to become a liability? There are hidden costs of data. When you're moving data to and from the cloud, the egress costs tend to add up very quickly. People have run into challenges with costs in the cloud, and that's not something that they expected going in. It's not something that they planned for. But then you layer on top of that space, power, cooling costs, carbon costs, costs of managing data redundancy, security costs, compliance costs, the cost of actually skill sets to manage this growing complexity, and of course, opportunity costs. By creating all this waste, you're actually putting barriers in place that result in you missing revenue, right? Excuse me, or diminishing competitiveness. I think when you talk about the concept of waste and how you handle waste, I came back to the idea of what Lean Six Sigma principles would look like. And you can start to actually apply that to your data, right? See, at Six Sigma, if you think of it, right, it basically says, when you look at a process, you optimize it by identifying where the value is, eliminating the waste by removing any non-value adding activities, improving the product and service quality, and reducing the cost. Add data to that. Use the same principles. Determine what data adds value to the process. Eliminate waste from non-value adding activities and non-value adding data. Enhance data quality. Reduce data costs while maintaining the value. We have to start applying these principles as we go forward if we're going to get efficient and see ROI from our data. Here's another quote from Mark Twain. He said, no, truth is, he'd never said data is the new oil. He actually said data is like garbage. You better know what you are going to do with it before you collect it. Let's talk about shift number 3. This is a shift that I call from risk to robustness. A couple of really telling charts on the left-hand side. If you look at that growth, and the x-axis shows 2002 all the way to 2020 and beyond, right? But this sharp spike in growth in terms of the number and types of cyber threats. Not just that, not just is the number of cyber threats going up, but the cost of cyber threats is also going up pretty dramatically. Data violations have grown 300% just in the last 5 years. And the average cost of a data breach right now is not only has it gone up by 25%, but if you think about the impact of it, $5 million per breach. Enterprises being able to factor this in and plan for this is a real concern right now. In fact, most companies say that they're not confident in having the right ability to handle cyber risk. More than 70% of companies, in fact, this number has gone up pretty dramatically, believe that they're underspending on cybersecurity. Let's talk about this as well, right? It's the fact that AI has exacerbated the problem. What we've seen with the sudden advancements in agentic AI just in the last couple of months, right? Or the emergence of OpenClaw, right? And what is actually possible. Some of the first things that we began to see is how these things security risks are exacerbated or exposed, right? How governance suddenly has become a massive problem when you have personal agents and trying to kind of put them under the guardrails of enterprise controls. AI has increased the attack surfaces, the exposure surface, but you also see that people are now more and more concerned about data breaches from AI-enabled attacks. AI-enabled attacks can be a lot quicker and more powerful and hard to stop, right? And making, in that case, the inability to recover data due to mistakes very high. Back in 2020, we were talking about the types of data being targeted being PII credit cards. 2025, it's about agentic vulnerability. 2028 to 2030, then this could even be much sooner than that. We're talking about critical infrastructure being at risk. Not just that, you think about what is going to happen as quantum computing becomes more and more prevalent, right? The idea that current encryption mechanisms, how are they going to be able to withstand quantum attacks? People have used the word quantum apocalypse, right? It requires a completely different approach. And this is why this shift is important. By the way, this is also exacerbated by a variety of geopolitical concerns, but all of this is hitting us at the same time. We have the emergence of the concept of sovereignty, sovereign IT, sovereign cloud, right? Forcing a shift in architectures and operations. Many countries are actually completely blocking data flows from crossing the boundaries of their country, especially when it comes to things like accounting, finance, government information, public information, other emerging digital services, telecom information, right? But a sovereign approach is something that is going to be one of the biggest and most complex challenges that we're going to face or have to contend with as enterprises over the next few years. It's not just about protecting your infrastructure itself and your data. It's about building local ecosystems, support systems, right? Access and control, locations, specific use cases for where data can be moved and not. How are you going to take care of completely revamped ecosystem, which is not global anymore, but more broken down into regional concerns? Yeah. Satya Nadella made a very powerful statement. He said, every company in the future, every company is a data company. And by extension, then every company must be a security company. Let's talk about shift number 4, right? And this is the shift from what I call the shift from control to coalitions. This may be a little hard to read on the slide. The text may be small, but this is a Gartner hype cycle, and this is the hype cycle for data management drawn up in 2024, right? And I've actually created these red dots across what I believe are things that are showcasing this point. Talk about inter-cloud data management, data meshes, data marketplaces, governance platforms, data fabric, data ecosystems, data lakehouses. All of these concepts are talking about places where management and control and view of data goes beyond individual companies. It goes beyond the boundaries of individual companies. We're now talking about the importance of thinking and working as ecosystems. In fact, in this context, I want to introduce you to this term. If you've not heard of it already, maybe you have, but this very interesting term coined by the author and speaker Cory Doctorow. Right? He talks about inshitification. And the title of his book, if you look on the left-hand side, says, Why Everything Suddenly Got Worse and What to Do About It. He defines it as the gradual deterioration of a service or a product brought about by a reduction in the quality of service provided, especially of an online platform, and as a consequence of profit seeking. Basically, think about it like this, right? When we talk about platform type technologies, companies that actually often build this, they start. Cory Doctorow talks about 3 stages of decay. In the beginning, they're good to users. They roll out these things, and there are many attractive features in the platform. And you can think of, even things like, your social media feeds or online shopping and things like that. In the beginning, it's all very attractive and lots of reasons why users would sign up. But then what tends to happen is the focus shifts from end users to the business customers, and the end users start to get abused, right? And they start to see negative experiences as ads and other things are built into the technology. Poor experiences start to proliferate. But then you go even further, and you're having these companies starting to claw back value from themselves, and everyone gets abused. The end user suffers, the business suffers, the company is trying to now at that point of time make profit. I don't think this is an unfamiliar experience for anyone. All of you can see places where this has actually played out. But the reason this is important is because what has happened in the context of this evolution is people working without full consideration for what is their true ecosystem, who are their stakeholders, how do you actually make sure that data and process and flows and value are flowing all the way from start to finish through your ecosystem, through a coalition. And this is the background of why I wanted to actually showcase this slide. Again, this is conceptual, but this is actually it's models and frameworks that are being used in practice to ensure that data value is maximized. On the left-hand side is the framework called the data value loop that basically says, from the creation of data, the communication, aggregation, analysis, and acting on that data is flowing across this ecosystem. It's not a linear flow. It is shared across the life cycle, right? Data is treated as a resource where the value grows as it is shared. And then you talk about the approach on the right-hand side, which is the concept of data as a product. What does data as a product mean? It basically means that you're creating and you're managing data with the end user and end outcome in mind. And right through the life cycle of data, you're applying those same principles. Tough product management principles that emphasize quality, usability, satisfaction. By the way, if you actually design it that way, you're addressing the problem of waste also, as we talked about before. You're not just creating better experiences and more utility and value from data, you're now actually able to reduce waste in the system. Yeah. Here's a familiar face from the last few decades, Robert Noyce. He said knowledge is power, shared knowledge is power multiplied. And I think he said it in a different context. But the fact of the matter is, you think about that now as we apply data strategies, it becomes very, very powerful. Shift number 5, and this is the last one, right? This basically is the shift from routines to returns. And of course, I've been alliterative throughout, so it makes it easy, hopefully, for you to remember. Look at the left-hand side, yeah, the promise of AI. And some of this may be a little dated from about a year ago, but we're looking at, the promise of AI being, hey, AI can deliver 3 times higher returns for companies that blend data with analysis. Predictions like saying there's going to be a 9% improvement in US productivity over the next decade. 25% or more of tasks are likely to be automated within the next decade. In fact, I think that if you're looking at the progression over the last few weeks, maybe people are being a lot more dramatic than just 25% and 9%. The impact is going to be a lot more than that. Here's the problem, right-hand side. 25% of AI initiatives have achieved their expected ROI. Only 16% of initiatives have successfully scaled across the enterprise. And this number, which kind of relates to some of the stuff we were talking about, is tech debt. 75% of tech leaders are going to be mired in moderate to severe tech debt when it comes to implementation. Yeah. This, I think, illustrates the real opportunity, but also the real problem. I like to say that that data is not just an IT problem; it's a business one. And this is my own framework that I've created to kind of demonstrate this, right? But it's an adaptation of Maslow's hierarchy of business needs applied to data infrastructure. What do businesses really want? Businesses, if you look from the bottom to the top, businesses want performance, things to work at the right time with consistency. But then you layer on top of that, when you've provided that, you provide trust, which is security, availability, reliability, compliance. Take care of that. You can start to unlock efficiency with IT optimization, with productivity, but also carbon reduction. And then you talk about experience, flexibility, simplicity, ease of management, some of the following the cloud-like experiences or the cloud standards that have been set, building that now into your infrastructure, and then being able to get to growth and flexibility. Some people focus more on the top, some people focus on the bottom. It depends on the nature of company you are. Enterprises need to essentially make sure that they are addressing all of this. But the key here is that data unlocks all of these things. Data can help drive real business value. And the reason I'm making this point is because you think of data as an IT problem or a business problem. The business outcome is what you need to connect this to. There's a very simple equation when you talk about return on investment, right? I want to start to use the term return on data, right? Because data as an asset or a liability, you have to be able to talk about the costs that go in and the value that you can derive from it in a very clear way. Let me actually clip this out, right? The value gained is both the hard, tangible gains, but sometimes there are soft, intangible benefits as well. For example, when you have data shared across an ecosystem, maybe you're not measuring the level to which it unlocks productivity across the ecosystem or better collaboration. But those are things that contribute to the value that's gained from data. The cost of data, as I indicated earlier, we have to not just look at the direct costs. For example, I'm buying capacity, right? Or I'm buying compute. But you also need to bake in the hidden costs. Hidden costs often tend to be I'm just shifting costs from this visible bucket to some invisible bucket at the back end. You do that, someone in the enterprise is bearing the cost. Your company is bearing the cost. But just because you don't see it, you can look, it looks like you're justifying an ROI. No, you've got to do this the right way. You do this well, and you're creating a return on data capability that looks beyond financial metrics, that really quantifies the contribution of data to business outcomes. No longer data for data's sake. You can justify data investments. You can drive data-driven decision making and an overall data-driven culture. Right? Put this into the context of how Hitachi approaches the world. Hitachi frames its strategy as the intersection of OT, which is operational technology. That's the real world. It's industrial applications, it's manufacturing, it's rail, mobility, it's energy and power grid systems. And IT, which is information technology. It's the underlying infrastructure and data. But when you put these together, that's when magic happens. That's when you're able to unlock real world outcomes through digital and IT. And in fact, I'm not going to go through the detail of it, right? But fundamentally speaking, the strategy is one that brings both horizontal scale with hybrid cloud, digital engineering, data and analytics, making that work across powerful IT foundations, but then being able to unlock value using vertical business outcomes, deep domain expertise, connecting IT to business outcomes. This blurring of the lines between the business and IT is one of the biggest implications of what's happened in the current AI era. Here now, AI is not amplifying insanity, but really impact and accelerating innovation. Hitachi Vantara itself is the data infrastructure arm of Hitachi, right? It's the data foundation, right? And I describe it in a very simple way. Just look at the acrostic over here, FIRST, flexible, right? Wherever the data is, however the data is structured, there's zero compromise in availability and simplicity and driving ROI with flexibility. But the second is intelligence, right? Bringing data smarts to bear, right? Which drives productivity, right? Drives AI ops, faster resource delivery. Resilience, right, which is guaranteeing data availability. It's unbreakable. You can shoot a bullet through it, and the infrastructure still stands. Sustainable, because as I kind of alluded to earlier, one of the costs of data is carbon costs, right, and power grid costs. You're not just trying to be good for the environment. Being sustainable or being efficient with your data actually saves you real dollars. And finally, the concept of trust. Trust is earned, right? And there's a reason why Hitachi Vantara is the bedrock of operations at key financial institutions, healthcare companies, governments, telcos, mission critical infrastructure. I'd like to end with this quote from a very familiar face. Jensen says that the most powerful technologies are the ones that empower others. And I think that's the concept of it, right? It's the technology that basically says data for what? What am I? It's not data for data's sake. It's not IT for IT's sake. What is the end outcome? How can we drive that real world outcome, right? Um, just to recap then, right? This is 5 shifts for your modernized data strategy. Start with data quality to build trust and business adoption. Prioritize data efficiency to reduce waste and drive worth. Don't shortcut controls. Design for robustness and governance from the start. Foster coalitions, both internal and external, and align them to your end user outcomes. And then stay ruthlessly committed to measurable business returns. I think I'm going to end with this one slide, which is what's next. Yeah. Just 5 things for you to do as you think about this. Number one, assess. How much do your data strategies directly line up with your company's stated business strategies? Data strategies and business strategies. How do they line up? Number two, what are your clear goals and measures, including return on investment or return on data? What are the KPIs that you're measuring? Will your desired AI use cases that you're prioritizing deliver in clear ways on these measures? The third is ally. Who constitutes the internal and external relationships and ecosystems that you need to build and foster to maximize data value and adoption? And are you engaging them early and often? Activate as you begin to execute your data initiatives. What are the mechanisms you need to put in place for control, for governance, for enrichment, for optimization across the data lifecycle? How do you measure that value? And finally, be able to refine, be flexible, be agile, continuously test, refine, and enhance your data and strategies as you execute for success. Ask these questions, and you're going to be able to find that your enterprise gets more efficient and you're able to now translate data into real outcomes and productize it across the enterprise. That's where I'll end. The
Simon,
future belongs to the data
thank
driven.
you. Thank you for that really insightful session. And I think one key takeaway that really resonates with me was, your point about data quality serving as this absolute foundation for establishing user trust, right, and empowerment, if you will, right. And of course, a crucial question: how can organizations capture data? You explained it very well from every single transaction, as you said, while ensuring then they use that as an asset, not as a liability, to really have a cost efficient, resilient, and as you just pointed out, sustainable way, right? Which is connected cost efficiency and sustainability. So really, really interesting. So a core theme, of course, of the conference is data and model readiness. And many organizations struggle because their data is trapped in silos. And you alluded to that. You talked about the geographies, right? The legacy systems. So for a global leader like Hitachi, which obviously operates across many, many industries, energy, rail, manufacturing, I was looking at even TV screens, right? I mean, it's a very conglomerate, in fact, right? So the scale of this data gravity must be immense. And when you are advising, let's say, a global enterprise on deploying AI at scale, how do you solve this kind of readiness gap that a lot of organizations have? Is it a matter of more centralizing data, or is it more decentralized? I mean, can you maybe talk a little bit about that in terms of these diverse industrial assets you have there?
Yeah. That's such a pertinent question. I've got that question so many times, right? And I think you really framed it well in terms of the context of Hitachi as a big global leader across all of these areas, right? I think fundamentally, I would say you don't solve the readiness gap by either one big cloud or by pure decentralization, right? You solve it by designing for, in summary, centralized governance with decentralized data and models from day one. At global scale, especially for a company like Hitachi, if you try to centralize all data into one cloud, it's neither realistic when you have so many different kinds of businesses across the globe, nor is it even desirable when you have safety critical regulated industrial assets and of course this concept of sovereignty, right? So most high value data is distributed across plants, fleets, grids, regions, often in systems that cannot be moved. And it also tends to be highly regulated and latency sensitive. So if you try to solve by centralization, what tends to happen is you run into massive data movement cost and time, you run into regulatory barriers, you also run into loss of local context and ownership that drives, what model quality and adoption. So what we see as kind of an answer to that is a governed data fabric over a mesh of domain data products. In fact, you could call this many things, but we call this a unified data layer. It facilitates a kind of data exchange, right? So it couples edge AI, federated learning so that models can move to where the data lives. And our Hitachi IQ solution actually does this really well. We have accelerated compute, we have a global namespace, we have high performance file systems. You can orchestrate across highly distributed data, but then you still need to centralize because what you need is governance and standards, especially, I think, in the context of agentic AI.
Yeah, it's very interesting. I mean, this also on a sovereign level, right? Centralization versus decentralization is a big topic, right? If you take the EU as an example, right, you have the regions and then you have the superpower, and it's kind of counterintuitive because you would assume more centralization leads to cost reduction, not to increase costs. Very interesting point. We're also seeing a shift, of course, to agentic AI, and we had guests from Microsoft. I think, had a quote from the CEO of Microsoft there. Autonomous systems that can negotiate, act without human intervention, right? And that brings, of course, significant risk. And you talked about risks there in your presentation. Yeah. To really have a secure deployment and, of course, compliance. You have a unique perspective on how to build trust, of course. You talked about that. So in an industrial or an enterprise environment where an AI error can have physical or massive financial consequences, where do you build the guardrails, and how does Hitachi Vantara help the CEO, for example, to ensure that their AI deployment remains compliant, remains secure, and especially when the intelligence is interacting with sensitive infrastructure. In your presentation, you talked about model incest, right? Yeah. Which is a real problem. So maybe can talk a little bit about that.
Yeah, agentic AI has really blown up the conversation around governance, hasn't it? In fact, if you to look at we just coming out, sitting where we are out of the NVIDIA GTC event and some of the events around it, the big thing that you heard different from before is the topic of governance, right? For agentic AI, as you described, right, in a plant or a grid or a trading environment, with the level of risk involved, the question isn't can the model think? It's what is it allowed to see? What is it allowed to decide? What's allowed to do? And who can prove that later? If you think of the work that Hitachi Vantara does, most of our customers, as I mentioned earlier, come from mission critical spaces, highly regulated industries like financial services, healthcare, government, telco. The impact of failing or being compromised in those industries is very high. So for us, governance is a top priority. So the way I would answer your question most directly is that guardrails belong in four places: identity and access, data policies, action authorization, and the fourth one is observability. Put those together. Right. That's how you keep autonomy. That's how you prevent AI from reconfiguring a substation or moving millions of dollars or transactions without oversight, right? And so, as I mentioned, our own Hitachi IQ offering, which brings in AI-ready but well-controlled infrastructure. We map to NIST and EU AI Act expectations. And of course, we've got deep in our DNA a heritage of decades of ethics and privacy governance. Obviously, these things are important. And that's why people trust these kinds of platforms. Yeah.
Right. Maybe to close, let's look at the customer and revenue impact. And a major goal of this conference actually is to explore how AI enables new product innovation and beyond, just making existing processes faster or cheaper. How is the deployment of AI at scale fundamentally changing in your company? I know at IBM there was a movement 20 years ago actually, moving away from hardware software to more being a consultant, right? Towards a future where you are essentially selling guaranteed outcomes to your clients powered by data foundation.
You're exactly right. The way you phrase that question is exactly the title of my presentation, which is data for what, right? But also emphasizing that the data foundation is a critical part of that for what. The big shift is not just cheaper operations, right? It's, as you said, it's AI plus your data foundation that lets you sell these outcomes, whether it is availability, uptime, resilience, productivity, energy savings, risk reduction. We're not just in the business of selling boxes and licenses. We're in the business of selling outcomes. And it's not just Hitachi Vantara, right? The entire Hitachi business is organizing around that idea. We have something that we call the Lumada business model, which is basically emphasis around as a service, recurring business and services-led businesses. Yeah. Our HMAX offering portfolio, that's a conversation for another time, but this really powerful intersection between IT and operational technology. And within Hitachi Vantara, we have something that we call Everflex. Everflex is basically our infrastructure as a service model. Essentially, we can wrap around SLAs around assets and software and infrastructure and AI-driven services in a way that we can actually translate this to ROI, that we can measure and that we can stand behind. So yes, we're absolutely moving towards guaranteed outcomes. I would say this, right? Those outcomes are only as strong as the data foundation and the AI ops under them. That's where the real advantage and innovation lives.
And just for curiosity, I mean, I mentioned IBM. What about Palantir? I mean, they do ontology, right? Also working with Data Foundation. Is that a competitor in that area, or is that someone that's complementing your offering in a way?
Yeah, as I mentioned, right? I think these are all potential ecosystem players and partners that can work together, right? There are ways in which our technologies and their platforms can actually combine together to deliver an overall outcome. So yeah, both of the players that you mentioned are essentially in that space. IBM may be more like a competitor, but they've also got things that can be added on. Palantir would be more in the extended ecosystem.
Fascinating. Simon, thank you. And this was really insightful to see how this foundation of AI is being built, not just in code, but in the strategic integration in data across many, many global industries. And to our audience, thank you for joining us at One Artificial Intelligence. I hope you leave the session thinking not just about what AI can say, but what it can actually do for your business. So I'm Henning Stein with One Business World.